second grade boys and girls. I miss you guys so much. This is Miss Niarco here. I figured I'd try this out as a YouTube video for you guys so that you can better understand what we're supposed to do this week. I know that last week was a lot, and like I said, there are no due dates on the assignments at the moment, so take your time, do the best you can, and pace yourselves out. I wanted to go over with you the lessons for this week. Last week we talked about the mountain model, and this week and of course erosion and weathering. And this week we are studying the accumulation of the small changes that happens during weathering and erosion. So just like last week, I want you to read through the lesson slides that I attached as a PDF and a PowerPoint. And you guys can either print out the worksheets, which are attached to the bottom of the PowerPoint, or you can write your responses on a separate piece of paper or record your responses in a notebook if you have one at home during this remote learning period. So here we go. So after you see that, you will be directed to the page on land and water text. Just like last week, please remember, please go to the Apps Learning Amplify website, and then you can plug in the username and password. And it says that in the tip here from my notes, you want to use an incognito browser. So that means you may have better luck accessing the digital text if you use a Google Chrome browser, or maybe you may use a Firefox browser or Safari or Internet Explorer. Whichever one works, please feel free to use. Once you get to the student books, please go to the Handbook of Land and Water. After that, your first task will be to go to page 51 in your notebooks. Remember, your notebooks are the worksheets. So the worksheets I post on the slides are the worksheets also at the bottom of the PowerPoint slides for you to print out or just look at and reference. Okay, so here the task is just to use the handbook for land and water to fill out the chart. Name the landform in the text. Choose two landforms. Name one of them. How did the landform change? A small change and a big change. And then, would you be able to see a big change in one day? Yes or no? Okay, so that's your task for that page. Then it says, go to pages 11 and 12. They're about beaches, but they don't have evidence about small changes leading up to the big changes. So it says here, page 13, the heading, How Beaches Change Slowly, tells me this page may have ideas about small changes leading up to big ones. So look at page 13 in your digital text so that you can better understand the evidence and the details about the small changes leading up to the big ones. Next on page 14, it says, this page describes how a beach might change quickly, but this won't help us understand small changes adding up to big ones. So, if you look at the text on top of the diagram on page 13, it will help you explain the process of how a beach gets smaller or erodes. And it says, let's look at the diagram and captions to find evidence that support the idea that small changes add up to a big change. We're going to fill out the first row of the table based on the information we read about the beaches. So what you read about the beaches on those pages we just discussed, you use that information to fill out the worksheet on page 51. Then it says read about two other landforms and complete the notebook pages. So that's basically the same direction that I just shared with you guys. And if you look at the table of contents, the bodies of water change too. So you can choose a body of water to read about. Of course, they can't be there to read with you, but you can choose a body of water that most interests you. I know you've been studying bodies of water with Miss Cassandra in the past, so I know that you guys are experts on this information. Right, so let's review and let's review the directions and questions together. So here you are asked to use the ideas from the mountain model and land and water to answer the following questions. So this is your worksheet page 52. Okay. It's highlighted here where they want you to fill in your answers, your responses. Then here it says your key concept that they want you to understand is that many small changes that are hard to notice can add up to a bigger change that is easy to notice. Okay? We can't be there to watch the recreation center erode, but we can study it, right? By investigating through text and lab investigations and models how smaller changes lead up to bigger changes during erosion. It says here, from the mountain model and handbook Land and Water, we concluded that many small changes to a landform can add up to a bigger change that is easy to notice. We also observed that erosion takes a long time. We'll investigate how long it takes by sorting cards with changes caused by erosion. So it says here, for page 53, use the scientific language on this page while discussing how to sort the erosion cards. I'll show you the cards, and I'm going to show you how I printed them out for you. So it says here in the task, these are your erosion cards. You do not need to print them out if you cannot. Just read the information on the cards. So you have A, B, C, D, E, F, and what they want you to do here, like in the picture, you can sort them out from shortest amount of time to erode to longest amount of time to erode. So it says that these are your erosion cards, and I attached them to the PowerPoint. You do not need to print them out if you cannot. Just read the information on the cards and sort them out in front of you, or sort them out as a written response on a separate sheet of paper or a notebook. So you literally can, write shortest amount of time to erode, longest amount of time to erode, and sort the cards out that way. Or you can make a T-chart and all the information about shortest amount of time to erode on those cards. You can write the information on one side, longest amount of time on the other side. We've been thinking of scale as how big or small something is. Geologists think about erosion at different scales when tiny pieces of rock cause a big change to a landform. Geologists also think about erosion at different scales when they think about how fast or slow erosion occurs. So, this is what we've been investigating these past couple weeks about the recreation center and its erosion process. Now, part 2 of your lesson for this week is an end of unit assessment. So it says we've been investigating how erosion could cause a big change to the cliff without people noticing. Today we'll write explanations about erosion. Revising ideas based on evidence from investigation is an important part of how scientists learn about the world. It helps them come to better understand how things work and happen in the world. Remember, boys and girls, even though we may have explained the possible observations and reasons as to why or how the cliff eroded, we can always revise or change, add, take away some of the ideas that we previously recorded, because we're always learning something new about the procedures we use to investigate a problem. You're constantly changing your ideas, constantly changing your ways of answering questions and investigating problems. So let's see what we can come up with in our writing about possibly how the cliff eroded over time. So it says here in the end of unit writing, explaining a big change to the cliff. So as a scientist, you're going to be answering the question, how did the recreation center's cliff erode without the director noticing? The director wasn't there. You as a scientist weren't there. Think about our rock candy erosion, or any of the experiments we did and discussions we had about how rocks erode in water and with wind. How do you think that cliff eroded? Okay, when scientists write explanations to answer questions, they support their answers with ideas they learn while reading and investigating. There are many places to look for ideas to help you complete your explanations. We've explained why the director did not notice the cliff eroding. Now we need to decide whether the recreation center should be closed immediately. Next, we will create diagrams to include with our explanation. The diagrams will help the director decide whether to close the recreation center right away. So once you look at the picture and the captions, I want you to be able to make a hypothesis what the cliff may look like 1 year from now and 1,000,000 years from now, giving reasons why to both responses. The diagram looks different from others we've completed. Instead of showing how the cliff got to be the way it is today, it shows what will happen to the cliff in the future. So you can complete your diagrams, including the captions, the highlighted area below. Should the director close the recreation center right away? Why or why not? We've been thinking about stability and change in ways that are similar to how many scientists think about stability and change. We've found evidence of small, slow changes to the cliff, even though it seems stable from day to day. What is something here in our classroom or school or home that seems stable from day to day? Do you think there might be slow or small changes happening to that thing? Think about it, boys and girls. Message me on Google Classrooms if you have any questions. I will be here for you this week. Have a great night.